root file system. And the VFS vget is one of your main utilities. We'll talk about that in a sec. And these are all in your struct VFS ops. Your vnode ops are vop, open, close, read, write, etc. There's a huge list of them. And they're defined in your vnode ops table. It's not a static table. It can be changed. You just swap it out. It's a pointer. And yeah, you can define several vnode ops functions. So why would you want more than one vnode op vector? Because of directories. You can't unlink a non-empty directory. You can't create files inside of a file, etc. So basically, because directories are different from files, they're different from pipes, etc. So your file system driver has two main tasks: bmap, which finds blocks, it's block map, and alloc allocates them. So basically for putting stuff on disks. The framework doesn't support ACLs or permission checks because not every file system supports framework ACLs and permission checks. Where are we? Oh yeah, so you would want to use your vop get page and put page, which are normally used for memory for mmap, but these are the ones that do the actual I/O. So your read and write would, for instance, call into your get page and put page, and there's a very good reason for that, and that's because of caching. If your write routine writes to the disk directly, and you still have a page in cache that hasn't been synced to the disk, and you write to that one as well, you can't resolve which one it should go for. So your write should always call into your put page. So vnodes, your VFS vget creates a node on this file system. This doesn't actually do the disk I/O, but it creates a node in your data structures. So all of your creates and lookups should call the VFS vget. VF lookup makes an internal representation out of this by calling VFS vget. Alloc and free, the actual vnode structures. The framework doesn't do this. Exists and invalid lets you show hide the data structure. So you can do things like you can have the data structure actually sitting there, just not active. And the actual call for this would be you call vop create would call VFS vget, which would call vn alloc, vn setops, and that would call vn exists, and that shows your vnode structure. So you can have the vnode structure. Once vn exists is called, you now have a vnode structure, and it has fsops, it has a data pointer, etc. A vnode lives as long as it's locked. It holds and increments a reference counter in the vnode data structure. After it's held, you can call any of the vop functions. So you can do your reads and writes and stuff like that. After vop, you'd want to call vn relay, which decrements the reference counter. And when the vnode is no longer in use, vop inactive would write your file access times before inval and free. VFS vget is not a vop function, it's a VFS function because vget doesn't start with the vnodes. It operates on the file system itself. It's a direct hook into your metadata, so your file system lookups and so on. So syscalls get vnodes from the implementation of create lookup calling vget itself. And vget will return a cache and avoid I/O if possible. So if you've already got stuff sitting in memory, you don't need to do actual disk I/O. And inactive, vop inactive, is a good place to do your file system flushing, so if you need to flush back to disk. And I have a whole bunch of links here, which you should be getting. It's a link to the device driver tutorial, writing device drivers. There's a couple of tutorials on how to write a file system driver. There's one that's a video tutorial. It's actually pretty good. Gen Unix has a writing file systems page, which is sort of half done. and the kernel source code is another place. For things like finding a network driver, you can look, if you want to write a network driver, you can look right into the kernel and find a couple of decent examples of it. DNet is, DNet.c, which you can just search for, is well documented. It's got, I think I have it up actually. Let's try this again. It doesn't want to let me. Yeah, if you look at the DNet driver, you have a whole bunch of comments on things like, I don't know, used for buffers, and where are the comments I was looking for? Oh yeah, it has things like, it'll tell you exactly where your module loading entry points are, where probe is. So DNet's not a bad example if you want to just take a look at it.
Colleague committed a driver called VR, which is very small and elegant. DNet is complex primarily because there's real hardware behind it that is very complex as well. There's a lot of hacks to work around deficiencies or straight quirks in the hardware. Or the VR driver, which is very recently takes effect. It's very clean. So somebody looking at network drivers, I think that would be where I would see it.
The
VR.
Your VR?
Yeah, I think it's about 1,000 lines of code.
And there are a couple examples of just really well laid out drivers, the ones that Garrett wrote. The file system driver is a little bit more difficult because nothing's documented and things do weird things. And
maybe you could use Cassini as a learning example.
yeah.
What's that first name on this again?
But yeah, I don't know. If there's any questions, I'm going to crowdsource them and ask Garrett. So if anybody has any questions, then go ahead and shoot them out, and we'll point them over to Garrett and whomever else feels like answering.
Quick question.
Yeah?
Could you elaborate a little bit what you need to do in the device driver to make it play nicely with like suspend, resume, and other power management features?
Power management, yes. That was something that I did not find. It is documented in there somewhere.
Yes, and in fact, there's some material online. At the first OpenSolaris Developer Summit, I did a quasi-live conversion, actually, of DNet to support suspend resume. It's actually quite straightforward, at least in the API calls that you have to make. There's some challenges with dealing with the fact that the real devices lose power and you have to save state and restore state. I'm more than happy to try to find you some examples if you.
I don't think that presentation was videoed, but I was in that presentation, and yeah, you did it in like a half hour. You got DNet to suspend and resume.
Yeah, it's not, for a typical driver, it's not crazy like a frame buffer. Frame buffers are weird and need special magic. But for a typical network driver or an HBA, it can be done in an hour or two for a typical device driver.
Can I just point out that Sherry Moore's presentation tomorrow about x86 cluster will cover quiesce and suspend and resume, because she did a lot of the work to get that happening.
Oh, is she doing suspend and resume as well?
Yeah. Oh, cool. Yeah. Are there more questions for John? No. Right.
Well, thanks, John.
Yeah, thank you very much.